Let me demonstrate using some of these other thread pools with the same prime numbers with thread pool examples. So we refactored this to use a fixed thread pool of size 3. And then we said, okay, we want to execute this using this executor service instead of creating threads ourselves. We made our program to be very, very simple. So we are actually going to be changing this to use a bunch of other thread pools. Okay, so for example, instead of a fixed thread pool, I can use a new cached thread pool. And this one does not take any arguments to the constructor because this does not need me to specify the thread pool size. Now what happens is, you remember this instance where we ran this thing and we gave it a large number of things to calculate, and then the other things were just blocked. So if I were to give it a large number and say calculate this prime for this thing, this is going to keep a thread busy. It's going to keep it occupied. It's going to give it one more. That's going to be occupied. Another one's going to be occupied. It's going to create new threads. Now, if I were to enter a small number, see, the small number is not waiting for these bigger numbers, which it actually would have if I had used a fixed thread pool and then I had taken off all the available threads. Then this would have been on hold. But now I'm not going to put it on hold. So now it created this new thread. And now if I don't ask it to do anything in 60 seconds, this thread that was created for the small number is going to get removed and garbage collected. All right. So that's the benefit of the cached thread pool. Again, you notice here that I just changed the creation of this thing. I didn't have to change the left-hand side. The left-hand side is still an executor service. It was the fixed thread pool earlier. Now it's the cached thread pool. Both of them have the execute method, so I didn't have to change anything. This is kind of similar to how the collection APIs work, right? So let's say you have a list, L equals new array list, all right? So if you change this to a linked list, well, you don't have to change the left-hand side because they all use the list interface. So the executor service is kind of like the equivalent of that in the concurrency paradigm. You can use these various different executors and still use the executor service interface to submit these events, to execute these events. Let me change this to a new single thread pool executor. So you'll notice here now that it's going to be a single thread which is going to do all the work. And now I just need to enter one big number for this to hold off all execution. Okay, so let's say I enter a small number, it's going to execute it. If I enter another number, it is going to use that same thread to execute this as well. I just enter one big number and then it's choked. That single thread is executing this big thing. Now, if I were to say enter another small number, well, it is not going to return the value because this thing is waiting for this thread to complete, right? So this thing is going and sitting in that blocking queue, waiting for this thing to complete. And only then, once this is done, this thing will be executed, right? So it's kind of like a fixed thread pool with a size of 1. Okay, now I want to introduce you to the concept of the schedule thread pool by switching over to this other example, which is the holding threads thing. If you remember, we had this kind of like a reporting thread, which was running constantly and saying, hey, how many threads are executing? So that's this actually, let me switch this back to a cached thread pool so that it's, or maybe make it a fixed thread pool, because I want to show you the advantage of using that instead of the thread.sleep that we did before. Okay, so this is what is this doing? This is basically getting threads and then just executing them with a thread pool size of 3. Okay, now let's say we want to use the same functionality. We want to build that same functionality into this program where there is a thread which runs something on a constant basis, right? Let's say every 5 seconds it prints out a report and say, hey, these many threads were, these many prime numbers were calculated. Okay, so how do I do this? Well, now I can, of course, create a new thread, like pass it to this execute and then have a thread.sleep, but there is a better way for it, which is the schedule thread pool executor. Okay, so what I'm going to do here is I'm going to create another executor service. So I'm going to call this scheduled executor equals, and again I'm going to use the executors dot new scheduled thread pool as the executor service, but now the scheduled thread pool executor service is going to need a thread pool size, and I'm going to make it 1. I only need one thread to execute at a time because it's just going to be one reported thread. Note this is not the actual limit to the thread pool, right? It's just the starting point. This can expand to as many threads as it's needed. All you're specifying here is how many threads you want to start with. Okay, so now I'm going to do a new runnable. I'm just going to print something to the console, okay? Just a temporary method over here, which just prints something that calls this thing running the report. And I want this report, of course, it doesn't print anything in the report, but basically I want to have this run every 5 seconds. Okay, so what I can do is I can pass this to the scheduled executor. But if I were to look at the methods on the scheduled executor, there isn't anything that's specific to giving it a time. Okay, so if you look at the executor methods, these are all generic methods which any executor can use. Okay, but what I want is to use something which is specific to the scheduled executor. Okay, so what I'm going to do is I'm going to change this to use the scheduled executor service. Okay, and this is going to allow me to use scheduled executor dot, and now I can use the schedule method. Okay, the schedule method takes in a bunch of arguments. If you look at the method signature here, it takes the runnable itself, it takes a delay. It takes a delay, like how much time does it have to wait before the execution happens, okay? And there is also, let me see, there is a schedule at a fixed rate, okay? This is where you want the task to recur, okay? So this one takes a runnable. It takes the initial delay, like how long does it have to wait for the first run to happen, and then the period, which is after how long does it have to repeat the execution. Okay, so here we have two methods. One is the schedule, which is basically just one-time run, and then you have the schedule at a fixed rate, and of course this also includes the initial delay. And now we have a time unit, which basically says what's the time unit. Do you want it to be in seconds or minutes or hours or whatever else? So I'm going to use this in order to schedule my task, which is this runnable. I'm going to pass this. Okay, I have called this a run as well, so I'm going to call this a reporter runnable. Okay, so I'm going to pass this report runnable and say I'm going to schedule this to run maybe 1 second after it has been scheduled, but then I want this to run every 5 seconds, right? After this is complete the first time, I want it to give it 5 seconds and then run it again. And when that completes, give it 5 seconds and run it again. And I'm going to give it the time unit dot seconds. Okay, what I'm doing here is passing this thing. This is schedule at a fixed rate. Sorry, schedule is basically just takes one time. Schedule at a fixed rate is what has this signature, the runnable, initial delay, and how much delay for each run, and then the time unit, which is seconds over here. So now notice what happens. I can run this, and the report thread is going to run every 5 seconds. It's going to give it a delay. So you see this runs, give it 5 more seconds. It's going to run again, and so on. So this is super simple, and I didn't have to do a thread.sleep and all that nonsense. I just have this, which executes. It's so simple. So what I'm going to do is I'm going to put this at the bottom over here after the executor service has been created. But now what I want to do here is print out how many threads are currently running. Okay, so I get that from the executor service. But now again, the executor service doesn't have those methods. I cannot get the number of threads from the executor service. I know that this is a fixed thread pool, so I'm going to call this the thread pool executor, and I'm going to cast this so that this thing is considered a thread pool executor. I know that this is a thread pool executor because I'm getting a fixed thread pool. So I'm going to get this, instead of using an executor service as the interface, I'm making it more specific. Again, the analogy is rather than using a list, you would use an array list for accessing methods which are unique to the array list. So even though this is an executor service, I'm using the thread pool executor service handle to get thread pool executor specific methods. So here, if I were to do the executor service dot, I'm going to get the active count. All right, so this is going to give me the number of active threads, and I also have the executor service dot get completed task count. Okay, so you can go to the Java docs and see some of the other methods that are available to you, but these two are very handy for me. Okay, so what I'm going to do is I'm going to do a sysout and then active threads, and I'm going to print this, and then completed threads, and I'm going to print this. Okay, so this is going to be my report. So what did I have to do? First, I used the thread pool executor as my handle so that I can get all this stuff over here. And I'm using that in my reporter runnable. And my reporter runnable is being scheduled at a fixed rate so that this just keeps printing every time. And every time I pass something to the executor service, that is what is going to run the stuff. But then I don't have to actually do it myself. I have the service doing it for me. All right, so I'm going to run this. It starts out saying the active threads is 0, completed threads is 0, which is what you would expect because I haven't run anything. Let's say I give it 2, well, with the proper syntax, of course. 2, then it prints out the result, but now the number of completed threads should be 1, which it does, and the number of active threads is 0. Now, if I were to enter a really long number, now the next time the report runs, the active threads is 1 because that's actually calculating it. Completed threads is also 1, which was the one that I completed earlier. Now, if I were to enter a smaller number, it is going to print it, and active threads is still 1, that long calculation, completed threads is 2. So what we've done is we've kind of used these new paradigms, the executor service implementations, to run what we did earlier, which was using this loop to calculate prime numbers, but then also having this report run constantly and printing things out. And this thing is not that great. I mean, like, we saved creation of a new thread and all that stuff, but the benefits we got aren't visible on the output. We have a fixed thread pool, and we did it just by using this one method call. The benefits of using this reporter thread scheduled at a fixed rate are immediately apparent because we didn't have to do thread.sleep, we didn't have to do all of that stuff. We use this API to say, hey, just run this thing at a certain amount of time, and the scheduled executor does all of that work for us, and the code is much cleaner as a result of it. So this is using the scheduled thread pool, the fixed thread pool, and we also looked at the single executor, which is basically just one thread at a time.